Hey guys, welcome back. This is section 11.7 on hydrogen orbitals, and we'd been talking about the s orbitals that you can see in this. The s orbitals are spherically symmetric. Um, they have nodes between concentric shells, but they don't have any nodes that divide them in half or anything like that. We also learned that as you go from 1 to 2 to 3, the orbitals get larger. That represents the electrons having more energy. We also learned about the p orbitals. The p orbitals have two lobes separated by a node. Um, I think I'll leave it at that. The p orbitals have sublevels because you can change their orientation in space. You can line them up facing the x-plane, y-plane, or z-plane, and because of that, there are three sublevels to the p orbital. So again, p tells us the shape, and then the xyz tells us which way it's pointing in space. You'll also notice that these are all 2's. There is no 1p. We'll see why that happens when we connect all these numbers and letters to the periodic table later on. So there are the s orbitals. Now there are the p orbitals. Look, s orbitals have no nodes. P orbitals have a single node that divides them. The other pattern that we might recognize is that there is a single s orbital with no sublevels. Or you could perhaps say one sublevel, but there aren't, there's no way to orient an s orbital in space. A single p orbital will have three sublevels. So we go from s, no dividing nodes and one sublevel, to p, one node and three sublevels. By extension, the next one should have 5 and 2 nodes, 5 sublevels and 2 nodes. And in fact, it does. We call these d orbitals. The d stands for diffuse. And each one of these has 2 nodes, and now there are 5 sublevels. So there's definitely a pattern here, and seeing that pattern might help you be successful with the shapes and the orbitals and how they work. So these are all 3D, 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 3D. There is no 1D, and there is no 2D. Again, we'll see why that's the case when we get to the periodic table later on. You don't have to understand these subscripts. I'm not going to ask you about the subscripts. But what you should take away is that there are 5 D sublevels. Each D sublevel, with this exception, looks kind of like a clover leaf. It's divided up into 4 separate lobes. These pictures don't really look much like a clover leaf, but if you had to draw this, a 4-leaf clover is a pretty good way to draw a d orbital. What else can we say about these d orbitals? Here's just sort of a philosophical take on this. If you look at the d orbital, it's not that the electron is in one of these lobes at any given time. In fact, because electrons are waves, the electron is in all of these, all 4 of these at the same time. As soon as you do anything that take a picture, so to speak, of the electron, as soon as you take any action that would tell you tell you where the electron is, the electron has to choose a spot, right? And so you can almost think of this as the shape of an electron, right? If you have a hydrogen atom, and its electron is in a d orbital, it's in all of these places at once until you force it to pick one particular spot. If you don't like the philosophy of it, you can kind of ignore that, but that's the way we believe the universe truly is. Trying to think if there's anything else we need to say about these d orbitals right now. I think we'll leave it at that for the time being. So S has 1 sublevel, P has 3 sublevels, D has 5 sublevels. There should be another one with 7 sublevels. That would be the pattern. S does not have any nodes that divide the orbital. P has 1 node. D has 2 nodes. The next one should have 3 nodes. And in fact, this is what they look like. And if you look at these long enough, you can convince yourself that in fact each of these does have 3 nodes. And there are 7 of them, of course. These are the f orbitals. You say, jeepers, Cato, does this just keep on going indefinitely? And the answer is, yeah, it does. F stands for fine. Let's review that a little bit. We have s orbitals, p orbitals, d orbitals, f orbitals. And that's where we're going to stop. The S stands for sharp, the P stands for principal, D is for diffuse, and F is for fine. After the F orbitals, it just goes in alphabetical order. So G, H, I, J, K, and so on and so forth. But we're going to stop with F orbitals. 7 of them, 3 nodes, and F orbitals have, well, we'll take a look at how much energy they have when we get into the periodic table. You'll notice all these M numbers here. You can ignore these. These are some of the quantum numbers. Basically, when we talk about quantum numbers, we're going to simplify it a little bit. We're going to say that, where did I put it here? We'll just do it this way. We'll say that the number tells us the size. So as you go from 1 to 2 to 3, the orbitals get larger. And although I didn't show you, there are 2 p orbitals, but there are also 3 p orbitals that are larger, and then 4 p orbitals that are larger again. I didn't show you this, but there are 3 d orbitals, and then there are 4 d orbitals that are larger. There are 5 d orbitals that are larger again, and so forth. So the number is going to tell us the size. The letter tells us the shape. S is spherically symmetric. P is sort of a figure 8 with 2 lobes. The D's are 4-leaf clovers, and the F's are these complicated but kind of fascinating shapes. And that's where we're going to stop for the time being. There are 4 quantum numbers. You now know 2 of them. The number is the size, the letter is the shape. There is another quantum number that tells us orientation in space, and we're gonna stop there though. So this is everything you need to know for the time being on hydrogen orbitals. And what we'll do in the next section is we'll take a look at something called electron spin. And what that's going to do is tell us how many electrons we can stuff into each one of these orbitals, sublevels. If you have questions, certainly don't hesitate to write to me. This is all very new information, very visual information, and perhaps confusing information. So the more questions you ask, the better off you'll probably be. Good luck.